Hey Twitch, how's it going? So we're back with another video. The last one we were looking at how we can set up OpenVAS functions and build them up in a mono repo, run them on Circle CI. But what we also need to look at is we need to look at how we can manage servers. Because quite often you're going to be running your OpenVAS server yourself. So what I want to do today is I want to look at how we can set up Kubernetes on DigitalOcean using Terraform and Packer. Okay, so why are we going to use Terraform and Packer? Well, the reason that we're going to use Terraform and Packer is that I want to sort of introduce a concept of infrastructure as code. And when you follow an approach of infrastructure as code, what you get is a capability to have consistency, to be able to reproduce your environments. You define your environments using this like declarative config, that HashiCorp configuration language, HCL, which you can see here on this screen, just a very short snippet of it. And why are we going to use Packer? Well, with Packer, what we do is we build an image, and the image is going to have our sort of base for our Kubernetes cluster. So then we will use Terraform to deploy that image into DigitalOcean. At the end of it, what we'll get is the ability to create a Kubernetes cluster that we can deploy OpenVAS on with two very, very short commands. And it's always going to work, theoretically. And you can reuse it. So we're going to create this up as a module. You can pull this example source code and you can kind of play around with it and modify it to your own needs. But first things first, I want to introduce to you Terraform. Okay, so Terraform is a tool for provisioning resources in a number of different sort of environments. You've got a whole bunch of cloud providers. You can see that you can deploy resources to AirCloud, Azure, AWS. You've got Chef integration, Docker integration, DN Simple, DigitalOcean, GitLab. Like, it goes on forever. But the concept is you use this very sort of this configuration language, and no matter what resources you're deploying or where you're deploying them, they're all defined in this very sort of common way. Now, it's not an abstraction. So a resource in AWS is not going to be the same as a resource, an AWS instance is not going to be the same as a DigitalOcean instance. They have different attributes and different inputs and outputs on them. And that's fine. I mean, it's all about sort of learning the language. We're not after getting abstractions. We're after about having this declarative framework that you can use to declare all of your resources no matter where they are. Some of the other things you can do with Terraform is that you can use Terraform to sort of provision things like graphs in Grafana. So we can use the Grafana provider to configure data sources. We can use the Kubernetes provider to provision pods and services and all sorts of stuff in Kubernetes. We can use the Nomad provider to provision jobs in Nomad. And again, it's all in this sort of very sort of decorative language. You commit it to GitHub, you can version it, you can share it with your teams, you can write modules. It's pretty awesome. But rather than me talking about it, let me show you. Okay. So what's the first thing that we want to do? Well, the first thing we want to do is just set up our provider, our base provider. So let's go across to the documentation for the DigitalOcean provider. And I will, why can I not see DigitalOcean? Who knows? Anyway, so what you need to do is you need to set up the provider. So the provider is is your kind of entry point. It's kind of where you configure the API tokens or the credentials. Then you have your resources, and the resources represent things like a droplet in DigitalOcean or a load balancer or something like that. And what you also have are things like variables. So variables allow you to configure inputs and outputs. You can have, inputs. Outputs are something completely different. You can have data elements, so you can query certain things in the thing, and a resource kind of loosely maps to an API element in the sort of underlying cloud or resource. So first things first, we need to set up our provider. So the provider declaration is here. And you can see that we need a DigitalOcean token, which we can either provide as an environment variable, or we can add it as a Terraform variable to this block here. So let's go and create that config. All right, so I have a completely blank repository here. So I'm going to initialize it. And what I'm going to do is I'm going to create my first Terraform file. So Terraform picks up files with the extension .tf, and it only picks them up from the folder that you're currently in. It doesn't recurse into subfolders or anything like that. Those are reserved for modules. So let's create, and I'm just going to make that a little bit bigger for you to make it easier to read. Let's create our first file. So I'm just going to call it main.tf. It doesn't have to have a specific name, but main.tf kind of makes sense. And let me just open that up in Vim. And again, I'm just going to make that a little bit bigger. Okay, so what I need to do is I need to add my provider block. So very simply, I can just copy this provider block from the documentation. So I'm going to paste that in there. Now, what I'm not going to do is I'm not going to input the token via a variable or using this command here. I'm going to use environment variables because I find that using environment variables for these things gives me the greatest portability. So if I'm running this on CI, then most of the CI providers have got the capability to inject environment variables safely and securely. If I'm running it on my desktop like I'm doing now, then I can use a tool called direnv, which I really like. And I'm going to use direnv, so let me just quickly show you how I'm going to do that. Okay, so firstly I'll save that. Okay, so we've only got one file in here. So direnv, what this allows me to do is it allows me to define environment variables that are only available to the kind of like a local scope. Well, basically this folder. So whenever I change into my Terraform DigitalOcean K8s folder, direnv will automatically load some environment variables for me. So if I do direnv edit, then I can kind of start adding my variables to this file. So I am going to do export, and I want DigitalOcean token, all in capitals. And I need to set that to my DigitalOcean token. So to get my DigitalOcean token, what I need to do is I need to go over to the DigitalOcean's website. I need to create my account if you haven't already done so, but I have. And then I can use the API link and I can generate a new token. Now, I don't want to show the entire of the world this API token, because then you can go and create your own resources in my account using my balance, and that's not fair. So you've got to think about these things. So always keep your environment variables, which are for tokens, private. Make sure you don't commit them to public GitHub. In fact, just don't commit them to GitHub. The last thing you want is somebody abusing your account because they've scraped through all of the GitHub repos and they've managed to find your API tokens. Keep them safe. So I'm just going to switch to a top secret window whilst I generate a new token. And I'm going to give it read and write scope. And I'm going to paste it into my direnv. So Terraform has, direnv has reloaded the local environment variable. So now DigitalOcean token is available for me. Okay. So let's create something simple, just so that we can, and look at what I just did there. That, I don't even follow my own advice, do I? I leave my API token on the screen so everybody can see it. All right. Well, I'm back on top secret because I'm just deleting that. And I'm going to start again. So I hope I've just proven how easy it is to expose your API tokens. So now you don't need to make that mistake. So bear with me 1 second. Apologies. All right, good. Let me just check that I'm not doing the same thing again. Nope, I'm not. Okay. So now that I'm not showing you my API token, and I've deleted the old one, we've already created our provider. So the next thing we need to do is we want to create a droplet. So let's have a look at the resource syntax for creating a DigitalOcean droplet. So you can see in Terraform, that's fairly straightforward. The minimum that we need is the image. So this is an Ubuntu 14.04, 64-bit image. We're going to give it a name, so that's the name you want it to appear in your DigitalOcean account. The region that you want to spin it up in. So of course DigitalOcean is available in a number of regions across the globe, so you can choose the one that best fits your need. Normally that's the one that's closest to you or your customers. And then the size, so how much RAM do we want to sort of allocate? So for this example, let's just literally choose those defaults, and I can show you how easy it is to create that resource in DigitalOcean. Right. So I'm just going to copy that. I'm just going to paste that into my Terraform config, and I'm going to save that up. So because this Terraform config's never been run before, what I need to do is issue the command terraform init. And what terraform init is going to do is that's going to download any modules or any providers. So all of the providers, such as DigitalOcean, are distributed as separate binaries so that they can all be independently versioned. But we've got that anyway, so we've downloaded the DigitalOcean. The next thing that we can do is we can run the command called terraform plan. And the cool thing about terraform plan is it's going to show me what changes I'm about to make to my environment. So let's have a look at that. So I'm running terraform plan. Terraform is looking at the state, so that's the current state, against the configuration, and then that will determine what changes or deletions or additions are going to be made. So the difference between the current state and the configuration equals your plan. And in this instance, we are going to create a DigitalOcean droplet called web. Now, there's two ways to do plan, and the preferable way is that when you run a plan, you specify the out parameter, save that to a disk, and then when you run Terraform apply, it's going to use the plan from the disk. If I run Terraform apply on its own, again, it's going to run a plan first internally, and it's going to tell me that I'm going to make this change, to which I'm going to answer yes, and it's going to go away and create it. Except it won't, because the region isn't available. So that's useful. I've got some handy error messages. So let's have a look at the DigitalOcean regions. Now, droplets. If I go to, let's create it in London 1, because I'm in London. Now run my apply again. So that is currently being created. So if I go back over to my droplets window, you can see that my droplet is coming up there. So Terraform is going away, it's creating it. You can see that it's currently taken like 25 seconds to create a VM. That's pretty decent in my book. And again, let's just confirm that in the sort of the DigitalOcean UI. We can see that we've got our droplet, and it's been created, and it's got all sorts of things like an IP address and stuff like that. Now that's awesome, but what we need to do really is add an SSH key so that we can log into this, and we haven't assigned an SSH key. So let's do that now. So let's have a look. SSH keys, this is a parameter, and it says that a list of SSH IDs or fingerprints to enable in the format. To retrieve this info, use the tools such as curl with the DigitalOcean API to retrieve them. Well, I think I can get them through the UI, but I'm going to add a new SSH key, and I'm going to get the ID of that. Then we're going to modify our Terraform config. What is wrong with my mind? I only need to add the public part of the key. I'm pretty sure I do. Oh, wow. It's been a long day. It has been a long day. All right. So let's have a look. I'll show you this as I do it. So I'm going to add the SSH keys. So the SSH key that I'm going to add to DigitalOcean is obviously just my public part. And the reason that I couldn't find my private part and I was struggling before is because I store them on an external device. Oh, never mind. So let's add that public key into here. So what I'm going to do is cat ID rsa.pub, and I'm using a Mac so I can pipe that. Oh, wow. I shouldn't do this on a Friday, should I? I really shouldn't. Anyway, So I've got my public part of my key there, and I'm just going to paste that into there, and I'm going to call that UB key, because that's the key that I use. And then I can get the fingerprint. So I'm going to copy the fingerprint, because what I need for my droplet is to add SSH keys, which is the fingerprints, like so. So then back to the Terraform config, I'm going to modify my resource to add this argument. So SSH keys. I think this is going to work, but we'll see. So I've made a change to my Terraform config. Let me just run Terraform plan again. Okay, so it's saying that my SSH keys should be a list. That's fine, because I can make it a list. So the difference between a list and a string is quite simple, that you obviously encapsulate a list in these square brackets, and you can just do standard stuff, standard kind of array notation. Nothing special going on there. So run my Terraform plan again. So Terraform plan, what's it saying? It's saying that it's going to change my droplet, and it's going to add an SSH key. So let's let it go ahead and do that. Terraform apply. Okay, so that has now changed, which is nice and easy. So what we should be able to do now is we should be able to log into that machine. So I'm just going to copy the IP address, and what I can do is just SSH. I'm not entirely certain what the user is. I'm gonna guess at root. Do I want to log in? And it's asking for me for my password, which it shouldn't be doing, unless of course it's not root. Let's have a look, see if we can figure out what the user is. So the only other thing that I can think of is that it hasn't actually added my SSH key. So tell you what, I'm going to show you how easy it is to destroy a resource in Terraform, and I'm going to recreate it, because that's the beauty of immutable infrastructure. It's just so easy to do this. Terraform destroy. Yes. So again, that's just going to take a couple of minutes, but we've just destroyed that resource. And again, if I go back to the droplet, just refresh that window there, and it's gone. So Terraform apply, Terraform deploy, really, really, really easy. So let's try SSH IDs or fingerprints. Let's try that again. Let's recreate our droplet. Terraform apply. It's telling me that it's going to create a new droplet. I click yes, and in 25 seconds, I'm going to have a new droplet in DigitalOcean. So that's, I mean, in general, that's pretty easy as the basics. You've got how many lines of stuff there? 7, 8 lines of stuff to be able to automate the creation of that droplet. I think that's pretty decent. And there we go. It's been created again. Now, one of the things is that, and I'm going to show you this now because I think this is quite useful. This IP address here. Now, if I have to keep going into the DigitalOcean UI to get the IP addresses of my newly created machines, then that kind of defeats the purpose of being able to do everything through infrastructure as code as the command line. But I don't have to, because what I'm going to do is I'm going to show you output variables in Terraform. So let's have a look at the docs again. So the docs have got these arguments. So these are our inputs. But it also has these attributes. And the attributes are things that go out. Yeah, outputs, kind of. And I can set up a special variable type in my Terraform config called an output, and I can reference, for example, this IPv4 address. Let's have a look. Very, very straightforward. Keyword output. I'm going to give it a name. I'm going to call it web IP. And then I'm going to give it a value. Now, this is where things are pretty cool, because this value I can actually get through a thing called interpolation. So I use this syntax with $ curly bracket. I reference DigitalOcean.web and then a parameter. So what the interpolation syntax is going to do is that when Terraform's automatically going to work out that the DigitalOcean droplet has to exist before it can populate the output variable. So by using the interpolation syntax, I'm always guaranteed that the output variable will be populated after the resource. It doesn't matter, you know, where I put this thing. I can put this up here, or I can put it in a separate file. There's no ordering based on file position. It's all based on the way that the graph is built and using this interpolation. So now, if I run Terraform refresh, which is just going to refresh any of my output variables. Normally you don't need to run this, but it was because I added the output variable after running my plan and apply. We can see that I've got my web IP, which is 159.65.49.169. So what I can do now is I can SSH into that machine. But I'm going to show you another trick as well, because typing in that SSH ID is just way too much hard work. So I'm going to SSH root at subshell Terraform output web IP, and it's automatically going to pull that variable out of the Terraform config. And you can see now, because I'm actually using the right SSH key on my droplet, I've got a shell to that machine. So that's an up and running DigitalOcean droplet. Pretty cool. So let me close that shell. And I'm going to destroy that. Again, beauty of Terraform, because we've got this declarative config, it doesn't matter how much more complicated I make this. I could create three different droplets. And in fact, why don't I show you? Let me show you how quick it is to create 3 droplets. So say I need 3 resources. well, the hard thing about creating 3 resources is that I've got to add a count variable. So I've got to say 3. I also need to modify my output syntax ever so slightly, because I've now, my web droplet is going to be an array of items rather than just a single one. So I can each index them like this, index 1, 2, etc. Or I can just use where's my star gone? I have lost my star. I can just use the star. So quickly back over here, no droplets. Now we're going to create 3 droplets. So you can see my Terraform plan is telling me that there's going to be 3 items. And they're currently spinning up in DigitalOcean. So again, if I refresh my window there, you can see I've now got 3 instances being created in the London region. 20 seconds, 25 seconds now it's taking. Wow, that's terrible, isn't it? Taking a whole 25 seconds to create a virtual machine. I think that's pretty awesome. And now, rather than having that that single instance where on my IP address I'm outputting my resources, I've actually got 3 instances. I wonder if I can I do this? I don't know, I've never tried this before. No, I can't. Can I do this? No, I can't. All right, not to worry. We can do it the old-fashioned way. Just to prove that they're up and running. Once that connects, there you go. So there's our instance. Again, Terraform destroy. It's telling me that it's going to destroy 3 of the droplets, and I'm going to choose yes. Okay, so that's Terraform. But the thing is, with that, we've got a bare machine, but it doesn't have Kubernetes on it. So what we need to do is we need to create ourselves an image using Packer. And then when we create our DigitalOcean droplets, what we're going to do is we're going to use our image. So we're going to pre-install all of the stuff like Kubernetes. We're going to put Docker on there. We're going to make sure we've got our network driver and all of those nice things. And then where we are just going to use that image, create our droplet, and then we can connect the cluster together. So this is going to be interesting because I am a Packer absolute novice. So this should be interesting for you learning that I don't know what I'm doing. Seriously, it can't be that hard. Anyway, so Packer. So Packer is an image building tool. You configure your kind of provisioning things like I want to install this, I want to install that, I want to set this up and do that. And Packer will go away and it'll build you an image. And you've got various different builders. You can use DigitalOcean, EC2, Ali Cloud, Azure, blah, 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 etc. We're going to use DigitalOcean here. But we write Packer configuration, unfortunately not in HCL. We've got to do it in JSON, but it's not the end of the world. JSON's not that bad. It's all right. So let's give it a go. So what I'm going to do is I'm just going to try the basic example here. So let's go over here and we're going to add a folder. I'm going to call it Packer, and I'm going to call this k8.json. So this is obviously not a K8 instance yet, but it will be. API token, again, I'm going to load from my environment variables. And right, let's see how this works then. Should be fairly straightforward. So I have the Packer command line tool installed. Packer, like a lot of the HashiCorp tools, is a single binary. You can install it either from releases.hashicorp, or you can use brew or a number of different methods. They pretty much run on every system, I think. You can run them on Windows, Linux, Macintosh, Raspberry Pi if you're working on a Raspberry Pi. Pretty much anything you can get Go to compile for, you could probably get our tools to compile for. But as a standard, they're available for pretty much most of the common platforms. So the command is that we want to do Packer build, and we want to build from a template. So Packer build k8.json. Fail to parse template. Unload root level in template image. Well, I have no idea why that is, so we're going to have to read the docs. Builders. Oops. API token for auth must be specified. That is fine. But come on, Packer, can I not use my environment variable? So API token, it's using a different type. The variable's ever so slightly different from the one that's using on Terraform. Yeah, that's right. I completely messed it up. Okay, so top secret mode again, while I edit my environment variables, because I don't want to show you the DigitalOcean token twice in an hour. That wouldn't be good. Right. Oops. So Terraform uses the environment variable DigitalOcean underscore token, but Packer uses DigitalOcean underscore API underscore token, which is no big deal. I'm just adding those both to my DIRN environment. Right, and back to the codes. So we got our Packer build K8's JSON. So there we go. So it's creating a temporary SSH key for the droplet, and then it's creating the droplet. So the reason it creates a temporary SSH key for the droplet is because it's going to provision the droplet with its own SSH key so that you can then do things like SSH exec to install any software and stuff like that. So you can see that droplet has come up. Packer is just waiting for SSH to become available. It's connected to the SSH. I haven't got any provisioning configured yet on this, so it's just shutting down my droplet and waiting for the snapshot to complete. So what we can do is, let's run that again, but let's start adding some of our provisioning steps. So previously I kind of said that, you can use, if you're familiar with Chef or Ansible or Puppet or Salt or whatever it is, then you can use those with Packer. Packer will integrate and allow you to use your Chef scripts or anything like that. I don't have any Chef scripts, so I'm just going to use Shell for the time being. So I'm basically just going to execute commands over SSH. So again, if we have a look here, we can use all of these different optional parameters. We can use a script, so we can specify a build sort of script, and then we can sort of upload that to the machine and execute it. But what I'm going to do is I'm just going to do simple SSH commands inline for the time being. So I need to add that to my K8s file. So I've got my builders section, but in addition to my builders section, what I'm going to need to add is provisioning. So let's have a look. Provisioners, maybe. Let's just double check the configuration for that. Yeah, there we go. So provisioners like that, and then we have this object array. So I'm not going to echo foo because that seems like a bit of a waste of time, but what I will do is I will do apt get update sudo apt update. And then what I'm going to do is let's start installing kubeadm. So we need to install Docker and all sorts of stuff like that. So let's start going through and adding that. So I'm literally just going to follow the setup guide for kubeadm on kubernetes.io. Most of this stuff can be done from shell. So the first thing we need to do is install Docker. So we need to do an apt-get update. We need to install HTTP app transport, C certificates, curl, and software properties common. That's all fairly straightforward. Then we're going to add the Docker GPG key, and we're going to add the apt repository for Docker, and then we're just going to do an apt-get update, and we're going to install Docker CE. So I can pretty much just copy and paste that into here. So, whoops. Let's add this, curl. Blah, add the repository. Oh, that's going to be interesting because I've got speech marks inside my speech marks inside my speech marks. I should probably do this as a script, shouldn't I? I think it's going to be easier. All right, let's abandon that. I'm going to create a bash script. And now it's going to be so much easier. So echo install Docker. So now here, rather than doing inline, if you remember from earlier, what I can do is I can use a file. So back to Packer, provisioners, shell. So script, the path of a script to upload and execute in the machine. The path can be absolute or relative. If it's relative to the working directory where Packer is executed. Okay, so script, and it's / install k8.sh. So theoretically, snapshot was created, blah, blah, blah. Okay, so I'm going to run my Packer build. It's telling me I've got too many brackety things, which I do. All right, so that's going, and that's going to create my droplet. It's going to execute my script, which should install Docker. And then it's going to save that as a snapshot, tear down the droplet so that I can then just use the snapshot. Going pretty good. I think we've done a reasonable amount in an hour, considering I'm learning some of this stuff along with you. We've managed to create our very, very raw and basic Terraform config to create a DigitalOcean droplet. We're now using Packer to start to provision Kubernetes. And we're currently, what's spooling out onto the screen now is just installing Docker, which is looking great actually. It says it's installed Docker there and it's shutting down the droplet. And the next thing we'll do, which will be the final bit for today's session, is we're going to use our snapshot image to create an instance in DigitalOcean, and then we'll SSH into it and see if Docker is up and running. So just waiting for that to complete. Again, I'm just going to refresh that on there, but you can see that I ran Packer twice here. The previous droplet has been destroyed. Just waiting. I should prepare some jokes or something for when you just got to sit around. I would normally just go and make a cup of tea, but that's not very interesting for you if I just get up and go and make a cup of tea while I'm waiting for this to run. But you can see here anyway. So these are the two snapshots that that I've created today. This was the first one that I created 10 minutes ago, and this is the second one, which now has our Docker on it. And we can see here the Packer is completed, and it's created a snapshot image with this name. So now, if I go back to my main.tf, so you see here where I'm using image Ubuntu 14.04x4, I should be able to use my image that I created with Packer. So what's the difference between Terraform and Packer? So they're both single-purpose applications. So Terraform will provision infrastructure. Packer will create images. So you can use Chef to provision applications and Packer to create images, which are snapshots of those machines, and then you use Terraform to deploy them, or something like that. Terraform for provisioning your infrastructure. Packer is for creating your images. So everything down the work line is immutable and reproducible. If you have an image, then no matter how many times you deploy it, the state of the cluster is going to be exactly the same because it's based on a known state, which is that of your image. If you provision your application every time you deploy it, then you're introducing the potential of change between each of those deployments. Packages could change inadvertently. You might not be pinning to a particular version. That could be a problem with an apt repository or something. You know, there's a number of different permutations that can change across deployments. So if you go all the way immutable, create your images with Packer, and then deploy them with Terraform, it gives you the greatest possibility for consistency when you're doing multiple deployments. I can recreate my infrastructure in almost exactly the same no matter where. So I could create a development cluster in DigitalOcean in London, I could create one in Amsterdam, I could create one, you know, a production cluster, a testing cluster. I can be assured that they're going to be as identical as possible by following this immutable approach with Terraform and Packer. Right, so let's see, anyway, let's see if we can, whoops. Let's see if we can use our newly baked image there. So again, image, I'm just going to call it Web1. I want to create it in London, 512 RAM. I'm going to load the same SSH key into it that I was using, which is my YubiKey, and then I want to get the output of that. I'm only creating a single instance this time. Okay, so Terraform plan, that's going to tell me that I'm going to create one droplet. Terraform apply, and what's it saying? So it's saying I've specified an invalid image. Now that's because I haven't got the image. What is the image ID then? Maybe I don't do it with an image. Maybe let's have a look at the Terraform configuration. Image, disk size. Droplet image or slug. So I've got a snapshot. 819. Create droplet. Wonder what the ID of it is. Do I need to use this ID perhaps? Let's have a look at that. Right, it is. So what I was doing before is I was using this as my image, but that's not the ID, that's the name. The ID, as explained quite helpfully in the Packer output, is ID. So when I change my image to use the ID, as the documentation said, I can create my DigitalOcean image based on the Packer build, which installs Docker and all sorts of good stuff. So let's SSH into that machine and see if it all has worked. I'm confident. Just SSH. Oh, the suspense. That's looking good. Docker PS. Oh, look at that. That's worked. I'm pretty pleased with that. So that's a pretty good start for an hour. So I'm not lying to you. I literally I've barely used Packer. I'm a developer, and even though I work for HashiCorp, I have to admit I hold my hands up in the air and say I've been bad and I've neglected using Packer, but it's actually a pretty amazing tool. So I've gone from zero to creating my first image today in DigitalOcean, and that's all happened within an hour. So quick recap, and I'll check all of this code in. So what have we done? So we created some Terraform configuration. We set our provider as DigitalOcean. We created a DigitalOcean droplet, and we added our SSH key to it. Now, originally we were using one of the standard images, but because we want to get to the point where we're running a Kubernetes cluster, we need to add some additional configuration to that. So we created a Packer template. We set the Packer builder to be of type DigitalOcean, which is going to create images in the DigitalOcean cloud. We specified our base image as Ubuntu 14.04, 64-bit, the region where we're going to create our image in London, size, and the SSH username. And then what we did was we specified our provisioner. So the way Packer works is Packer will create an instance inside of DigitalOcean, and then it will run the provisioners. So in our instance, what we're doing is we're running a shell script, and this shell script is going to install a whole bunch of stuff, including Docker. So again, that's something we run once, and then the next step is we're going to add kubeadm and kubecontrol and all sorts of good stuff like that, and we're going to spin up our Kubernetes cluster, which is going to be nice and easy because all we're going to have to do is add to this shell script here. So let's check all of that into GitHub. First things first. If you're not planning on keeping an instance hanging around, run Terraform destroy. When you're spinning stuff in the cloud, it's costing you money. So if you don't need it, kill it. And what we need to do is we need to add our stuff. into GitHub. Now, first things first, I'm going to give you a word of warning. This file here, terraform.tf state. So I've only shown you the basics today with Terraform. I haven't talked about remote state or anything like that. So the Terraform uses local state, which will be stored on your disk wherever you run Terraform plan. That local state potentially is going to contain secrets like API keys that you do not want to expose to the world. So the first thing is use remote state. It's very easy, but if you do use local state, make sure you don't commit it to GitHub. So I'm going to add a git ignore to make sure that my TF state and my TF state backup aren't committed when I push this repo. I think I actually have a global git ignore rule on this, but just to be safe, I'm going to add another one. So nvim git ignore. Again, I use direnv. I find it really useful to have kind of temporary environment variables based on a folder. So I don't want to commit my envarc file because that contains my DigitalOcean token, and I've already showed it to you once. I don't want to have to go and do that again. And I'm going to add the Terraform file. So terraform.tf state tf git status. So we've got a git ignore. Oh, we want to add the Terraform file as well, folder. So the Terraform folder is where it caches things like the various different plugins. So you can see there, plugins, and then in there we'll have, oh, wow. There we go, DigitalOcean and stuff. So we don't want that in Git either. Actually, if you create a project and set the git ignore as Terraform when you create the repo in GitHub, it's going to add most of this for you anyway. So the only files we want to commit are our git ignore, our main TF, and Packer. So git add all. That's going to be cool. Initial commit. And I'm just going to grab that name there. I'm going to hop over to GitHub. I'm going to wait for that to load. I am going to add a brand new shiny repository. And I'm going to call it this, and I'm going to call it Terraform Packer example for Kubernetes on DigitalOcean. I'm going to make it public. I'm not going to init with a README. I'll add the README in a little bit. And I'm just going to create the repository. And I want to do this before I finish the video so that I can share this with you. I'm going to do that, and then I'm going to push all of our configuration to GitHub. And now I will add a README. And I'll put some details in that later on. And that's it. That's a pretty good starting point. In an hour, we've gone from nothing to being able to set up and build images using Terraform and Packer. All of the code is here, so that is at github.com/nicholasjackson/terraform-digitalocean-k8. And I'll paste this in the links. Can I do that anyway? Oh no, I can't. I'm not using the same computer. I'll paste that into the links for you in just a moment. But next time, what we'll do is we'll continue with this. We'll continue building out our Packer scripts to install kubeadm, spin up our Kubernetes cluster, And then we will start adding some more stuff to our Terraform configuration to build a really nice model cluster. So we're going to add things like load balancing, we're going to add multiple nodes, we're going to connect them all together, and then that's it. We'll have Terraform configuration, which anybody can use. So you can just pull this module and you don't need to rewrite it again. But I hope you've learned something. And until then, thank you very much for watching, and I look forward to speaking to you next time. Laters.